welcome to the deep dive.
Hey there.
So for today's deep dive, we're going to unpack the space weather forecast for November 14th through the 17th, 2025.
And it is a really fascinating one. We're not just looking at one storm, we're looking at a complex, active handoff.
A handoff, right. From this just chaotic, severe event to something much more stable and recurrent.
Exactly. And to really get it, you have to start with what happened just before this forecast window.
The G4 storm.
The G4 severe geomagnetic storm. It was caused by what we call a cannibal coronal mass ejection.
A CME. Just a massive cloud of plasma and magnetic field.
A huge one. And this one was triggered by the biggest flare of 2025.
The X5.1 class flare from active region 4274. And that single event created a complete trifecta risk for operators, didn't it?
It did. You had an R3 strong radio blackout, an S2 moderate radiation storm, and then, of course, that G4 geomagnetic storm.
And that sets the stage for our first couple of days.
It absolutely does.
Okay, so let's jump into that first phase. We're talking November 14th and 15th?
Right. So this is the recovery period. We're expecting G1 minor to maybe G2 moderate storming early on the 14th.
So the Earth's magnetic field is sort of ringing like a bell after being hit.
That's a great way to put it. But the risk, it doesn't just evaporate.
Okay, hold on. If the main CME is passed and that G4 storm is over, shouldn't the danger be receding really quickly?
Well, that's the logical assumption.
I mean, that active region, 4274, it's rotating away from us now.
And that's where the physics gets incredibly specific, and it's why the risk stays so complex.
Okay.
For the geomagnetic storming, the G scale, you're absolutely right. CMEs from there will now be directed away from Earth.
So that particular threat is gone.
It's largely gone, yes.
It's like the water spray from the hose is missing us, but the hose itself is still hot.
That is a perfect analogy. The R scale, the radio blackout threat, that persists. We still have a 30% chance for strong flares.
Because X-rays just travel radially at the speed of light. Position doesn't matter as much.
Exactly. But here's the really fascinating part. The S scale, the solar radiation threat, it can actually increase in some ways.
How does that work?
Because that western limb position is what we call magnetically well connected to Earth.
Ah.
It provides this efficient spiral path, like a superhighway, for high energy particles to hit us.
Wow. So even on day one, it's still a multi-vector hazard zone for anyone managing satellite.
Absolutely. A lot to watch.
That makes so much sense. Okay, let's pivot. We're moving on from that complex chaos to the second phase, the 16th and 17th.
And here we switch drivers completely.
The total change.
They stop talking about explosive CMEs and we start talking about a recurrent solar wind enhancement.
So something much more predictable.
Much more. It's a stable stream of solar material flowing from a coronal hole high-speed stream, a CHHSS.
Which brings the forecast down to unsettled or active, with maybe a chance of a G1 minor storm.
A chance of G1, yes. A much, much calmer picture.
And this is kind of the aha moment in the forecasting tools, isn't it? If the previous G4 storm was such a huge surprise, how can forecasters have such high confidence in this little G1 storm?
It's all about which models you're using and why. If you look at the big picture of solar cycle 25, it tells a crucial story.
About the limits of those models.
Right. The long-term recurrence models, the 27-day outlooks, they completely failed to predict the transient G4 storm.
They were forecasting quiet conditions, I remember that.
Totally quiet. But, and this is the key, those same models successfully predicted the arrival of this recurrent G1 stream.
So you need both. You need the real-time eyes on the sun for the explosions, but the recurrence models still earn their place. Keep predicting that background activity.
You absolutely need a blended approach, especially now at the peak of the solar cycle.
So bringing it all together, what does this actually mean for you if you're listening?
Well, it means you start this 96-hour period managing a really high-impact multi-vector risk.
The G2 storming, plus the chance of R3 blackouts and S1 radiation.
A lot to juggle, but by the end of it, you transition to a lower impact, predictable, single-vector risk.
Just that G1 minor storming.
Right. And this whole period where a severe transient event overlaps immediately with an incoming recurrent stream, that is truly the story of the peak of solar cycle 25, this challenging complexity.
Which really brings us to the final thought we want to leave you with. The incredible challenge for forecasters isn't just about predicting the explosion or the slow, steady wind. The real difficulty, the art of it, is predicting the complex scene.
The transition.
The transition, exactly. That point where two entirely different universes of solar phenomena intersect and hand off the baton.